Okay, so welcome back, everybody. This is part 4 of our OpenSearch indexing deep dive. If I recall correctly, where we left off, we were in transport replication action, which is the parent class of the parent class of transport shard bulk action. So recall that transport shard bulk action is a subclass of transport write action, and transport write action is a subclass of transport replication action. So we were in do execute, which calls to run reroute phase. Reroute phase has its do run method. And at the end of that do run method, that when this method gets called on the coordinator node, it calls perform remote action, assuming that the primary shard is not located on the current node. That call to perform remote action finds the primary shard for the shard bulk action. And if it's on a different node, which usually it will be, it'll redirect, invoke this same transfer bulk action, which will, go through the same phase of the do execute reroute phase and hit the reroute phase's do run, rerun this whole method. But this time it'll call perform local action because this condition will be satisfied that the current node ID is the primary shard's node ID. So then when it goes into perform local action, it'll call perform action with this string with the transport primary action, which is defined as just the underlying action with primary action suffix. And we were looking into, so that gets redirected to, I just had that code up. Oh, yes. So there's this call here to register primary request handler. So yeah, yes, when the replication action is constructed, yes, the primary request handler is registered, and this will redirect it. Let's skip over admission control for now. And what happens is the handler for the primary request is this one down here, the handle primary request. So this ends up invoking this new async primary action .run. Now, before we dive into this, I just wanted to give a little bit of commentary. Yeah, as I was trying to remember where I left off the last video, I was kind of going through this and rewatching some of the video from last week. And one of the things I was reminded of is the fact that these the transport shard bulk action, and everything else that extends transport write action and transport replication action, you may have noticed that this action is executed first on the coordinator and then says, oh, wait, no, I'm not on the right machine. Let me redirect this to the right machine. This is not a typical service-oriented architecture, right? So a typical service-oriented architecture, you have different services that each have a function and each have their own APIs, and there's a well-defined API between them. This particular design where there's an action that runs on a node and then kind of says, oh, wait, no, this isn't the right node. Let's find the right node. This is not a typical way of writing distributed systems. And I would argue that in the current day, it's not the right way to write distributed systems. So I'm thinking that one of the things I'm going to do once I get to the office this morning is open an issue suggesting that we have well-defined separation between the coordinator role, as in, the node that happens to receive a request, and the node that ultimately executes the request, because that would make this code a lot easier to follow, in my opinion. yeah, this is one of these things that we have in OpenSearch that I strongly disagree with. You know, this notion that you've got these actions that it's really hard to tell, like, where does this action run? Does it run on the coordinator or at the shard level? And the answer is both. That's terrible. We should really fix this. So in the meantime, let's get down to the code that runs at the shard level. So, you know, the do run for, you know, the execute on primary. Oops. Didn't mean to click on the names here. Let's get yeah, do run. Okay. So we figure out what shard we're talking about. And okay, so one thing here, yeah, so there's this pending primary term. This is something that honestly so this is the primary term the index shard is supposed to be on. Yeah, I don't entirely know what this primary term is for, but maybe we'll be able to figure that out a little bit later. Andrew, are either of you familiar with the shard level primary term?
I think it's like the promotion, right? So it's still primary shard actually in the cluster.
Yeah. Yeah, like the comment here,
Yeah.
yeah, some relationship to primary promotion, but yeah, I'm
If not is, for example, that, and this was primary before, but not primary anymore.
yeah,
That's a primary term, I guess, would be.
yeah. But to use the word terms, you know, I'm assuming there's some relation to the word term in the Lucene sense. Yeah.
No.
Nope.
It's I guess it's it's a time frame during which the kind of the cluster is at
Oh,
state. So when the cluster changes, terms goes to next one, right? It kind of,
got it.
it's not this term.
Yeah, no, because that's where, you know, term of course
Yeah.
has a particular meaning. Then yeah, oh
Yes.
yeah, the fact that it's a long, yeah, okay.
You've been a long time with Lucene.
Well, yeah. Well, no, but the open source code is so intertwined with. I'm like, oh, okay. Well, clearly, this must be a Lucene level term. But no, okay. So it means like a term like
Yeah.
you know
Like there is election during
yes
the last election, it's still the same. So cluster
right
same state as the last election was. There is this kind of election term.
yeah yeah term like a term in office. Got it. Okay. Yeah. Okay. Cool. No, that
Generation might be a better
oh yeah.
word, but
Okay.
primary term is ubiquitous, right? And
Right.
it means the like opaque ID that was assigned upon election as primary.
Got it. Yeah. Okay. Cool. No, that makes more sense. Thank you. So yeah. So okay. So we figure out. So okay. So this is presumably double checking. It's like, hey, am I? Yeah. Yeah. If the request is associated, I guess, with this shard's allocation ID and yeah the request's primary term, and yeah, if we're in the middle of an election, or sorry, if an election happened while we were, oh yes, we may end up here if the cluster state used to route the primary is so stale that the underlying index shard was replaced with a replica. So yeah, okay, so yes, so this will, oh yeah, and in this case, this is the one where it's saying like, oh, I'm not actually a primary, so I'm gonna retry and send it to the real primary. So yeah, and then you know we get down here where you know presumably it's checking to see that yeah we're associated with the correct primary term, and then we acquire the primary operation permit, and then within that, yeah, so this is yet another one of these asynchronous things where we're going to call run with primary shard reference. gonna briefly, this acquire primary operation permit, what does that mean? Okay, so executes the logic for acquiring one or more operation permits on the primary shard. The default is to acquire a single permit, but this method can be overridden to acquire more. Briefly, yeah, and then we go deeper and deeper. Yeah, I'm not going to look into the shard operation permits for now. Let's look at run with primary shard reference. So again, we fetch the latest cluster state. We get the relevant index, check to see if the primary shard reference is relocated. So looks like in this case, once again, we can redirect the operation. So yeah, so this will once again do a similar sort of thing to that execute remote, but so yes, we can be in the primary delegation phase. But yeah, I believe this will only happen if we're in the middle of primary failover. But in normal steady state, we would go to this else block. So sorry, I'm just looking here. Okay, so this is the response listener that will try to invoke maybe sync global checkpoint. But remember, this is the callback that will be invoked later. So we're going to invoke this replication operation where we have the primary request, we have the primary shard reference, and we're going to call this execute. I'm just keeping an eye out to see if there's any other subtle, thing being invoked here. But it looks like we actually execute this replication operation. So we have the primary. So this is the replication operation dot primary, and we're going to call this perform on it with. So do we have a primary ref? No, this is in a test case. So we must have a primary shard reference. So, this is where we just keep going deeper and deeper because recall that we were in this perform on primary we were in handle primary request, which, ended up calling some kind of like handle primary. And now we're in primary shard reference dot perform, which calls shard operation on primary. So we just keep going deeper and deeper. So this is where recall that transport shard bulk action extended transport write action, which extends transport replication action. So now we're into transport write action. So this one, so we have an executor function, which we apply on the primary. So I believe this executor function, we probably set in our constructor, gets called from here. So let's see what this thing's executor function is. So what was that? Executor function comes before force execution on primary, executor name function. So this thing is, okay. So this thing's just, given a shard, we return a name. Okay. Okay. So yeah, similar to earlier at the coordinator level, you may recall from a few weeks back, at the coordinator level, we decide if we use the system write thread pool or the regular write thread pool, depending on if we're writing to a system index. Okay, so yeah, this is less exciting. So where were we? So we were on shard operation on primary, which calls here. Okay, so we're trying to decide which executor we use. So this is either going to be the system write pool or the regular write pool. And based on that, we're going to use that thread pool to execute this, which So here, I assume this is relatively recent code that is using OpenTelemetry to, trace how long do we spend in this dispatch shard operation on primary, which is abstract. So we can jump over here back to transport shard bulk action because it's got override. Okay. So here's where the transport shard bulk action decides what it's going to do on the primary. Well, and mostly it's going to call this perform on primary. Just looking through here to see if there's anything else exciting happening. So this mapping updated action. So this would be where we update the mapping based on dynamically added fields, which is another thing that I have opinions on. But we can get into that a little bit later, possibly later this hour. But yeah, let's wait till we actually get to mappings getting updated. But yeah, this is a listener, presumably, for when mappings get changed. So anything else exciting happening here? So yeah, that is just a generic listener for when the perform on primary happens. Okay. So we create a new action runnable. Okay, so a lot of stuff going into this action runnable, and then we just do .run. Okay. So we do this action runnable, presumably so that we have the safe finish request on success, and recall that action runnable overrides do run, and we'll have an on failure. So with the listener that was passed in, if an exception occurs within this do run, then the listener will be notified. So yeah, this is useful for asynchronous execution because obviously, if you have things running asynchronously and it fails and you don't notify your listener, then yeah, it'll just keep failing, or rather the listener will wait forever. Cool. So yeah, now within the do run, we're gonna delegate to execute bulk item request. So, which is also defined here in transport shard bulk action. Here's just why this one is static. I assume, yeah. Okay. So it makes it easier to test. So in practice, it's only invoked from this one place, but being a non-trivial method, the fact that it's unit testable in isolation is probably not such a bad thing. So, okay. So let's look at the current op type. Oh, yes. And so I'll leave this bulk item request. Sorry, I just want to go back for a sec. Context dot has more items to execute. I'm curious. So bulk primary execution context. So this request, as you may recall, is a bulk shard request. So it wraps multiple requests. So, okay, so we've got, okay. So yeah, so it ends up, implementing, this kind of iterator, I guess. So, where do we, so the request to execute is presumably the current item. Okay. So yes. Okay. So yeah, it can step through individual items, and once it hits this completed state, no further handling of current requests. Oh, and execution can continue to the next item. Okay, cool. So, okay, so they'll iterate through the underlying doc-rate requests, and they say, guess the current untranslated item request. So yeah, let's get into how this translation happens. Okay, so where were we? So we're going to while context has more operations. Oh, sorry, I was curious about this one. Yeah, where do we actually iterate? I guess we call execute bulk item request, and that does the iteration. And this one, yeah, okay. So cool. Okay. So we have this context. We call context.getCurrent. So this is just reading from the current. Yeah. It's reading from the current index. Now, this is assuming that the operation type, here we also read from the current in order to get the op type. And yeah, we do an if else. So this is if the op type is update, and then otherwise we just go here. What's special about update? Well, I guess, yeah, there's the fact that, updates need to be version. Wait, what else is special about update? Right? Because the op types here can be index, create, update, and delete, where index is sort of the default operation, or sort of an upsert, right? Where it will update the item if it exists or insert it otherwise. Create is an explicit insert where it will always append, and update requires that the thing already exists. So yes, so I guess that's why update is special, is because we need to prepare it. So I assume that, yeah, it needs to get the existing operation. So let's assume that for our purposes, let's pretend that we're doing an index operation. So we go down here. Okay, the is delete is false. So we end up down here. So we're going to get into this mapping update required in a little bit. But yeah, so that's part of the result. But we're going to get to this apply index operation on primary. So this will delegate to the apply index operation. And it just happens that in this case, we're applying it on the primary. Interesting. So for segment replication, we can skip parsing the documents as we directly copy segments from primary char. Well, yeah. Oh, and primary and routing entry.primary equals false. So yes, so this apply index operation occurs both on the primary and on the replica in the case of document replication. We want to still follow what's happening on the primary because we haven't gotten to replication yet. So we're going to call prepare index here. So recall that. Okay. Aha. So now so we're going to return this engine.index. So finally we're getting to this class called engine. Yes. And incidentally, as we talk about terms, this UID is a Lucene term. So this is where it's very important the documents have IDs, and these IDs, are mapped to the field named _ID. So this, because this _ID is essentially the primary key from a database, right? That, it is the unique identifier for a document. And so we create this index operation. So this index operation here it's essentially data object. If I recall correctly, looking over here at the index operation, yes, it is a pure data object. So index doesn't actually have, it extends operation. So when I say it doesn't actually have anything that can be invoked, I guess you have to look at operation, but so index, is purely a bead, meaning that, it holds state. Yeah, it doesn't actually take the action itself. It is the representation of the action that we intend to execute. And, at this point, when we create the index operation, we pass in the parsed document. Just want to double check. So we called new engine.index, right? So that was sorry, it's going to go back to where we were for a sec because, sorry, trying return new engine.index. I am curious. Okay, got this doc up. Okay, yeah, I want to make sure that I didn't miss this step. So, yes, we got the document mapper. Okay. So this is something that's deprecated that we should, well, trust. I would have thought to some extent. So types were something that were, if I recall correctly, they were announced for deprecation during the Elasticsearch 6 years. Starting with Elasticsearch 7, I think, if you tried to create a new index with document types, it would throw an exception. Saying, no. Types were marked for deprecation. You cannot create new indices with types. And, that carried over into the OpenSearch 1.x series, where you couldn't create a new index with types. And then starting with OpenSearch 2, we removed references to types. Curiously, this one, the document mapper for type, still lingers. But yeah, we should hopefully be able to remove this class in 3.0 because functionally it's not actually doing anything, right? Like it's just using document mapper. Document mapper, this is the thing that takes care of parsing documents and resolving to the underlying fields. Yeah. And, as defined by the indexes mapping. So, okay. And if I recall correctly, the document mapper, I think, actually also keeps track of when the mapping needs to be updated. Yeah. Well, there is this merge here that merges some new mapping information into this document mapper. And yes. So the merge reason, can be related to mapping update. Yeah. So first there's, mapping update pre-flight where, we send the mapping update to the cluster manager. And then presumably once we're done, then we do a mapping update. So let's jump back. We had created this engine.index. Okay. So this is the operation. It has the now parsed document where a parsed document actually has the underlying Lucene documents. So this document here is, a Lucene level document. The reason why it's a list is because if you have a nested document, so if you have nested documents, those all need to be indexed in one shot. That, when they get past Lucene, invokes the indexWriter.add document plural, which guarantees that those documents, the parent and its children, are indexed contiguously. Actually, technically, if I recall correctly, the children followed by the parent. Though, yeah, we'll see that for sure. I may be misremembering there. So, yeah, they get indexed contiguously, and that's how these parent-child block joins work. Yeah. If they weren't indexed together, then those block joins would simply not work. So, so that's why it's a list of documents. If you're not using nested documents, and this is specifically with the nested field type, not just generic, object fields. But yeah, otherwise, yeah, this list has size 1. So yeah, if you can often sort of assume, yeah, that this will have size 1, but not necessarily. What else? Oh yes, and we keep track of the media type. So the media type, recall when we were talking about X content, that the different types of X content are JSON, YAML, Smile, and CBOR. So yes, because we store the source, where this is the bytes reference here. So this is basically just the UTF-8 source. We also need to store the media type to know what the format of the source was, so that later on we can parse it. If we need to read from source, reparse the document, maybe apply an update, and then write it back as I go back. Okay, cool. So we've got the index operation. We had called prepare index in order to get this index operation. Where did that happen? How did we end up calling prepare index? Okay. Oh, what I hadn't noticed when we called this apply index operation. Yeah. So we're now on index shard, by the way. Yes. Because we called apply index operation on primary, which was called by the transport shard bulk action. Oh, okay. Yeah. So we had the primary shard, which is of type index shard. And yeah, that's how we ended up here. Cool. The index shard class, incidentally, there are a few of these classes in OpenSearch that are absolute monstrosities. We're soon going to get into the InternalEngine class, which is another one. Index shard is one of these ones where it's used a bit as like, well, yeah, this class is very overloaded. If you look at the number of fields that an index shard has, so the fields start here on line 255. Then you kind of keep going. There are a lot of fields in index shard. There's a lot of stuff. Okay, so yeah, I guess finishes down here at 363. But yeah, this is a lot of state in an index shard. Overall, the index shard file is over 5,000 lines. You see here, 5,398. Yeah, that's in my opinion too many lines in a single file, but in a single class. So it is what it is for now. This is probably a very good candidate to be broken apart. For example, we could actually separate out, maybe separate out memory shards from replicas. That could be a possibility. But, for the time being, let's go back to, okay, so we're going to try to apply the index operation on the primary. So we have this operation we've called prepare index. So here's where we look for any changes to the mappings with this update. Okay, so here's where, oh, interesting. So if we need to do a mapping update, instead of returning the actual operation, we see like, oh, wait, first we have to update the mapping. So with this, sorry, I just want to go back. So this apply index operation on primary, here we've got, So this is where, so we try to apply the operation. We don't apply the operation, right? Because instead of returning that index operation, what we did was we returned the new mapping update required, right? So, yeah. So we just said index result with update, where, created is false. Yeah. So that's kind of interesting. So as we go back to transport shard bulk action. So if a mapping update is required, so here where we get into the mapping. So here, okay, so we've got the primary shard, we've got its mapper service, where the mapper service, so this is the mapper service merge, not the okay. I was going to say, not the document mapper merge, but this ends up delegating to the document mapper, right? So, yeah. So in theory, this is a slight legacy thing where there used to be multiple types. You could have multiple types within a single index, but you can't anymore. So now we simply fail if this loop executes multiple times, right? And then, so we've got the document mapper, and we call internal merge, which eventually ends up calling this document mapper dot merge, right? So this is combining the mappings, like incorporating the dynamic mapping change. But this is just here on the primary shard, right? So, and the merge reason is the mapping update pre-flight. But first, before we commit to this, we will need to centralize the mapping update because it's an index level concept, not a shard level concept. So simply say, yes, on this primary, I intend to merge in this mapping change. First, we will need to propagate that. So we call to this mapping updater. So what's this mapping updater performer? So in practice, this is okay. So it'll be this lambda here. So which calls mapping updated action. So we're going to delegate to yet another action. So update mapping on cluster manager. Okay, cool. So this is where we end up centralizing this. We send this to the cluster manager, say, whoa, before we proceed with applying this index operation, I want to confirm that in the cluster state, the mapping that is global to the whole cluster, I want everyone to be in agreement that this mapping change has happened, and this provides some consistency. So cool. We've managed to kind of get to where mappings get updated, dynamic mappings get updated. I don't think I want to dive into update mapping on cluster manager. We've already seen node to node routing. Recall that with transport shard bulk action, we did this whole thing during the rewrite where we execute this method and we say, am I the host of the primary node of the primary shard? Sorry. If so, execute locally. Otherwise, do this execute on primary, like execute remote, where it figures out where the primary is and then routes to it. Functionally, cluster manager updates are very simple. So what this action will do, not going to dive into it, but essentially what this kind of thing tends to do is it asks, am I the cluster manager? If so, invoke this thing locally. Otherwise, redirect to the actual cluster manager. So we don't need to get into that. So where were we? So so if the mapping update is required, so we do this. We've called out to the cluster manager. We have this wait for mapping update, right? So we accept reset for execution for retry. So I assume that at this point, and then down here, we return false. So I assume that what ends up happening is we will end up, return true if the request completed on this thread and the listener was invoked, false if the request triggered a mapping update that will finish and invoke the listener on a different thread. Okay, so in the case of the mapping update, that's exactly what happens. So in this on response, so action listener will run after. Okay. And once this thing finishes, we're going to call this on response on the item done listener. But yeah, what does this reset for execution for retry? Okay. Resets the current item state to prepare for a new execution. So yeah, so it seems to me that this call to update mappings doesn't actually it's not so much that the callback for the update mappings indexes the item, so far as I can tell. Rather, it just sort of resets the item to say, okay, well, let's try this again. And here where so we do this if, right? And if this is true, so while this thing, okay, so if this thing returns false, rather, then we say, okay, we're waiting for a mapping update on another thread that will invoke this action again once it's done. So we just break out here. So now I'm kind of curious as to where that, okay. So we did pass in this item done listener. Oh, which invokes this. Okay. Okay. Yeah. So, okay. So yeah, that item done listener ignores whatever was passed and instead just invokes execute, right, to trigger the next item. But recall that we didn't actually advance the context to point to the next item. So, cool. So, in this case where we did the mapping update, we do all of this stuff to update the mapping. Here, in our item done listener, we say on response null, right? Because of course, as we just saw, the response is not actually used for anything. It just invokes that do run, invokes run, which calls do run, which will again call execute bulk item request. We add the context. The context works as an iterator. So in the case where, we never actually marked the thing as completed, right? Because we didn't actually, because we saw the result was, a mapping update is required. So we get back here, right? We get back to this result equals apply index operation on primary. So if we've got the case where we call apply index operation, we get the index operation. Okay. And now we're going to assume that this time a mapping update wasn't required. So we're going to get into index shard.index, which I think we're going to have to leave for next time. So very exciting. The next time we will definitely get to the point where we actually call into the Lucene index writer, because we're very close. Here in the index shard.index method, we have, so we're going to call this engine.index. The engine is the thing that holds the reference to the Lucene index writer. So, next time, I will give you a quick sneak preview. So next time we will get into, in practice, the implementation is InternalEngine and its index method. You scroll down just a little bit. Yeah, somewhere. Okay, not. I thought it was here. Okay, but yeah, I think this calls something, which will call index writer. Oh yeah, first we have to get into the translog stuff. But yeah, somewhere in here, we will get into. Oh, yes, somewhere down here. If the plan is to index the thing into Lucene, we will somewhere down here. Yeah, I think it's in this. Maybe put index under lock. Is that it? Yeah, somewhere down here, we are going to index into Lucene. But for now, I think we can leave it here at index shard.index, and we'll come back next time. Okay. Thank you very much for coming. And see you next time, or see you.
Thank you.
That's all, Michael.
See you guys. See you guys.